is your basic regular parabola. Okay, this is the one that everything else is based off of. We know that this one goes through what for its vertex?
Oh, it doesn't.
Point of origin.
Oh, it goes through the point of origin. Good. X, Y, it goes through the point of origin, and we have our nice parabola.
Okay.
Okay, we have our nice parabola, it goes through the point of origin. If we counted it out, there would be a distinct pattern there. I think Naomi was the best at that. She did hers by pattern. And I was really impressed that you were able to do that because the parabolas all fit the same pattern. Okay, so that's important for you to know. Now, since obviously people are coming back on. So what we need to do is we need to find out what the things are you can tell about where the graph will go, how the shape will change, simply by doing various different things to the basic pattern. We know quadratics always deal with something being squared. And what else is going on around it is going to determine where that thing moves. We have a basic form for a quadratic function. All of them can be written in this form. Okay, all quadratic equations can be written in this form. Okay, now, this one can be written in this form. Okay, this one, if I write this equation in this form, okay, sure.
Y equals 1 times x minus 0 squared plus 0.
Okay, if you were to take this, this is exactly the same thing as this. Our a in this form of the equation is 1. Okay, our h is 0 and our k is 0. I want you to notice something. This one, our basic starting graph goes through the point 0, 0. That's what these two right here are going to tell you what it goes through for the vertex. Okay? These two right here, the h and the k, tell you where the vertex is going to be. This number right here, if it's 1, means that it's going to be a standard pattern and it will look the same as every other parabola, but its vertex will be shifted. So what I want to do is I want to take a look at what if we had one that looks like this. Okay, we had one like this. We said this has the ordered pair of 0, 0 for its vertex. This one's 0, 0. So that would mean that this vertex Philip, where do you think the vertex would be for this one? If this one
3, 1, negative 3.
1. Just 3, 1. Good.
Nice. Yes.
Okay. Notice if it's in this format where you have x minus h plus k, the vertex will always be hk. Yes.
Why would we do negative?
Okay. Why would we do negative? The reason we wouldn't do negative is if we were to plug in the values. Just give me 1 minute. If we were to plug in the values to this, we would end up. If you plug in enough values, you find that the pattern will always just go backwards of what you're thinking about on the inside. Remember when you plugged in a whole bunch of them yesterday in your graphing calculator? It was always kind of the opposite for the thing in the parentheses than you expected. It turns out that way. Let me get you started with something just to give you an example. Let's try this one for a minute. Y equals, just hold on a second. I want you to do something for a moment. what I would like you to do is I would like you to make a table of values here. Now you can go over and over with this as far as plugging in, but what I would like you to do is I would like you to do 3, 4, 5, 6, 7 for your x values. I want you to find the y values to that, and perhaps you'll be able to figure that out. I want you to do that. I do need to talk to the person that just came to the door real quickly. This is nice. This is a 5, right?
She don't care.
4 minus 5. 1 squared is 1. Plus 1 is 2. 0 is 1. 6 minus 5 is 1. 1 squared is 1. Plus 1 is 2. This one's 5. Okay, good. So that's over.
Wait, hold on.
So,
How is the 35?
Wait, I got negative 45.
you got what?
I got negative 45.
Something happened. All right, look.
Can you do it real quick just until I can see this wrong?
Look. 3 minus 5 squared
Right.
plus 1 is negative 2 squared, which is 4 plus 1 gives you 5. That's
Oh, I foiled.
okay, right. You're plugging in for all the x values, finding the y values. The reason I did that was to convince you that this x minus 5 is going to move it to the right instead of to the left. So let's graph these points. Okay, so 3, 5 is here. 1, 2, 3, 1, 2, 3, 4, 5. That one's about here. 4, 2. I'm just making this hopefully make more sense to you. There's your 4, 2. Here's your 5, 1. And here's our 6, 2, and then our 7, 5 takes us back up here. Okay, the idea was for you to see, yes, it is a parabola. Now this goes back to section 1, but just so you see it one more time, look where the vertex is. When we said this is in this form, a times x minus h squared plus k.
Where did they get age and hat?
This is a format. You know how you have ax squared plus bx plus c, and those are all numbers? These are all numbers just like that. And when you analyze it, when it's in this format, it gives you a lot of information. Just like in a line, y equals mx plus b is a very useful form. This is a very useful form for a parabola. So here, we would expect that the vertex will always be hk. So our vertex for this one is 5, 1.
Oh, okay.
Because here's the 5, here's the 1. They're in the h and the k spot. And guess what? When we did this the long way, we found out that it was at 5, 1.
No.
Here's the vertex at 5, 1. Now, the other thing that's very easy to tell from here is the axis of symmetry. And axis of symmetry is always easy once you have the vertex. It's x equals 5. Okay, because it's always going to match that. When you have an equation, when you have a quadratic in this format, x is always going to equal h. And there's your axis of symmetry going right down through the 5. And so putting it in this format is going to be extremely useful.
Can you put it in the other format that we were doing a little bit ago? Can you put it into this format?
You can.
Minus.
Hold on a second. Okay, so in this format, Luke asked, can you put it in the ax squared plus bx plus c format? Sure you can. But I'm saying this is a useful format too. And what we are going to get to is where we can actually put equations that are in the other format into this format. But for right now, we're just going to analyze what's going on with the graph. Okay, so once again, the format for the quadratics, y equals a times x minus h squared plus k. So some of these you can think through. Some of them have some hidden zeros. We already talked about when you had y equals x squared and how that one had hidden zeros. This one also has hidden zero. Y equals x squared minus 3. Now, in this, if we were to write this in this form, and you don't really have to write it out physically, but mentally write this out in this form, what would it look like? Y equals, what would the a part be? 1 x minus what squared? This part here, if I put x minus 3 squared, you'd have to FOIL it and you wouldn't have this. 0. And this part right here is this part right here. Okay, here's the constant. K is, think K for constant. I know that sounds weird, but K for constant. So if there is just a number here by itself, this one's K. This one is a 0 that's hiding. So for this particular graph, when you were doing it in the graphing calculator yesterday, you noticed that this one went which way?
It went right. It went right and slow.
This one went down.
Oh, we both wrong.
If you look back in your notes, or you put it in your calculator, this one went down. This one, actually, for this, what would be the vertex based on what we said? The vertex is HK. Press it.
0, 3.
0, 3. 0, negative 3.
Wait, what? How is that negative? Oh, it's that side.
I got the
Notice
vertex. I
this
got it.
one.
Tell you the vertex.
Listen. This one right here is plus. So you have to make this one into plus negative. So this one is really 0, negative 3 for its vertex. Now what we need to do is be able to talk about what happens with the graph. This graph, when you graphed it, would it open up or down? In other words, would it be the regular U shape or would it be upside down?
It would be.
This was the regular one.
Oh,
Okay, this was the first thing we did. The only time that it turned upside down was when you had a what?
negative.
A negative over here, but we don't have that. So this one went down 3. There's your vertex. 0, 1, 2, 3 down. And it was a normal shaped graph. So it would look like this. Open upward. Now, what you're going to be asked to do is analyze, first of all, which way did it go? It went up or down?
It went down.
Down 3. Did it go left or right?
No.
You just went down. And it opens up. We call this opening up. And it is a normal width.
Can we just say, like, instead of opens up, can we just say minimum?
It will say, your choices when you take your quiz and test will be, it'll say opens and it'll say up or down. And you're going to need to choose up or down. This is an opens up. Opens down would be the other way. And the whole graph moved down 3 and the width is normal. Okay? The width is normal. The graph moved down 3 and it opened upward. Okay? The vertex is 0, negative 3. HK will always be your vertex. Okay, let's look at another one. Let's look at y equals x minus 2 squared. Okay? This one. Will it go will this go up, down, left, or right?
It'll go left.
Go.
No, it'll go right
It's
too.
going to go right to,
Somebody's gonna get wider.
and there's no coefficient here, so it's going to be a normal graph, opens up. Opens up, and it is normal.
What would happen if there was a cube there?
If there's a cube there, the graph will be kind of like a sideways S shape, and we're not doing that. Save that for your next course. Okay. That's not a parabola anymore. That's a cubic image. Okay, so this one moves to the right too, because remember when it's in parentheses, it moves right and it's a normal graph. If you needed to take a look at the graph here. And what would be the vertex for this one?
0, -2.
Good.
0,
No.
2, 0, 2. My bad.
Backwards.
2, 0.
2, 0.
What?
Yes, because you go over 2 and
It goes right to, there's the ordered pair 2, 0, there's your vertex. Okay, this is x minus h squared plus k. This is, the vertex is hk. hk. There's your vertex. So that's where the 2, 0 comes from. This is your basic format. A is just a 1. H is 2. K is 0. It moved to the right 2. Some of you that are more visual would rather sketch it first and then write down the analysis. Some of you would rather just write down the analysis.
Isn't the axis of symmetry 2?
Axis of symmetry is x equals 2, absolutely, Alvin.
X.
The axis of symmetry, perfect.
Can you find the
that's-
roots with that or no?
No, this one's not good for finding the roots. The other form is better for finding the roots. This one is better for describing the graph. Okay? So, what happened when you had something like this? Do you remember what this graph looked like?
Oh, it
Upside
would be
down,
upside
down,
down, and negative 2.
Upside down, and was it narrow or wide?
It was
Normal.
This one was actually narrow. Remember when we got the bigger numbers yesterday? The ones that are bigger than 1 or less than negative 1 made it narrow. So this number tells us that it's narrow.
And then the negative means it's upside down.
The negative tells you that it is upside down.
Or a maximum.
All right. Now, where's our origin for this one? Or where's our? I just gave it away. Where's our vertex?
0, 0.
0, 0. Because there's nothing added or subtracted to the x, and there's nothing over here. So it's still at 0, 0. Okay, it didn't move left or right, but it does open downward, opens down, and it is narrow. So you're going to be responsible for giving a basic analysis. Now these are very rough graphs, but that's all I'm really requiring for this particular part. I want you to know if it opens up or down. I want you to be able to know if it's narrow, if it's wide, if it's normal. We want to know if it's upside down or right side up.
Would that be a question of quiz?
Absolutely, yes.
Confused about this narrow and wide.
Okay, let's look at that part. If we have, here's our form. A times x minus h squared plus k. Okay, this one tells us how far that it's going to move left or right. This one tells us whether it moves up or down.
Smells like hand sanitizer.
this one, if it is, this one gives us two pieces of information. First of all, it tells us wide or narrow.
And up or down.
And it also tells us
That is the second person who got
whether it opens up or down.
The other person? Didn't even know about it.
Don't kill your baby.
Now, as far as how we can tell, if the absolute value of A
And that was a text message.
is greater than 1, then it is narrow. If the absolute value of A is less than 1,
He has wires.
it is wide. If A equals 1, if the absolute value of A equals 1, so in other words 1 or negative 1, it's normal. Okay? So you're going to look at that if you've got a big number or a number between 1 and negative 1. That's what this means, like the decimals, like 0.5, negative 0.5, it'll be wide. If it actually equals 1, it's going to be a normal looking graph. Now, I'll get in a second. It opens up or down based on if A is positive or negative 0, then it opens up. It opens down if A is negative. So this means positive. So A is positive means that it opens upward. A is negative means that it turns the graph upside down. Now yesterday when you were doing that with your calculators, it all was making sense. Now you're going to need to be able to do it by looking at the equation and analyzing it that way. What was your question?
How did you put like the y equals x squared minus 3 into the equation for any type of?
Y equals x squared minus 3.
It was a prior example. It's the only one.
Yep. Yep. If we had y equals x squared minus 3, okay? I know that some people are still writing down. But if you had y equals x squared minus 3, this part would be 0. This part would be minus 3. A would be a 1.
Now, if there was another equation like with another number in front of x squared, would that be the number that's attached to the
That would be this A, yeah.
Okay.
If there's another number that's attached, now there won't be another number attached inside the parentheses. The number comes outside, or if there's no H, then it might just be something like 4x squared.
And if you had an equation like that, would you how would you put the two coordinates?
If you had, give me an example equation. If you had an equation like
The y equals x squared minus 3. If how would you know if the x coordinate would be 0?
okay, well the x coordinate is zeros.
Nicholas McLean to the school office, please. Nicholas McLean to the school office.
Okay. All right, look. If we're trying to put this into this format so that you can analyze it. Hold on. Because she had a question on this. Now look, if this 3 were in here, okay, you know that x minus 3 squared would be x minus 3 times x minus 3. You'd FOIL it, and that would equal that. Okay, so what you want to do is you want to take this and make it look like this so that you can figure out what the graph looks like. Even if you don't write it, if you can mentally say, wait, this is the constant, that's the k. So this one tells me up or down. So this one right here is plus negative 3. That's the constant part. When I just have x squared, there must be something here, you just don't see it. So the only thing I can subtract and still get x squared is 0.
So when would it not be 0?
When will it not be 0? Like, for example, if you had literally something like something like this. Okay, something literally like that. Whole different question.
So you wouldn't
So then that means you got some, you got A.
would you see something like that in that equation? Would you have to turn it into that?
We will work on getting them turned into that equation from something else, but we don't have enough time to today.
Okay.
Preston slithered out of the kitchen.